This exercise gives us another opportunity to see the value of power series solutions to differential equations. We have y double prime plus e to the xy prime minus y is equal to 0. We're asked for two power series solutions of the differential equation. Our expressions for y prime, and y double prime are the usual ones, but how do we deal with e to the x? Well, we're using a Maclaurin series. And the Maclaurin series for e to the x is 1 plus x plus 1/2 x squared plus 1 over 3 factorial, so 1/6 x cubed, and so on, and it goes on forever. Before, when we had binomial factors, we distributed the sigma and then collected our powers of x. That's not what we're going to do this time. What we're going to do is we're actually going to just write out a few terms for each of the sigma expressions. Let's start with that multiplication. First, we're going to multiply everything in y prime by 1. So we're going to get c1 plus 2c2x plus 3c3x squared plus 4c4x cubed, and so on. Moving on to x, we're going to multiply everything in y prime by x. I'm going to line up my like terms here, so I'm going to put our plus c1x underneath our 2c2x, and then plus 2c2x squared is underneath our 3c3x squared. Lining up the x cubed terms is going to give us 3c3x cubed under there, and then finally we have 4c4x to the fourth, and so on. Next, we're going to multiply 1/2 x squared by everything in y prime, again lining up our like terms. That's going to give us a plus 1/2 c1x squared plus c2x cubed plus 3/2 c3x to the fourth, and just for kicks, plus 2c4x to the fifth, and dot dot dot. How many terms are we going to have to get? I actually don't know, but I'm going to keep going. 1/6 x cubed by everything in y prime is going to give us a positive 1/6 c1x cubed plus 1/3 c2x to the fourth plus 1/2 c3x to the fifth. I'm going to call that good there. Now folks, all those terms just represent the e to the xy prime term. We still need to reckon with the y double prime sigma and the y sigma. For the y double prime, we've got 2c2 plus 6c3x plus 12c4x squared plus 20c5x cubed, and so on. Then I'm going to take all those terms that we just generated, and I'm actually going to line them up underneath the terms that we just wrote down, and in such a way that all the constants line up, all the x's line up, all the x squareds line up. It's just a bookkeeping thing. Now we still have our minus y. So underneath all that, and again, I'm going to line things up, we have negative c0 minus c1x minus c2x squared minus c3x cubed, and then so on. I guess I can say minus dot dot dot. And all of that, folks, remember, equals 0 because it was a differential equation with 0 on the right-hand side. And as before, all the constant terms add up to 0. All the coefficients of x add up to 0. All the coefficients of x squared add up to 0, and you can see that we have all of them that there are. We've been pretty good about catching all of them here. So for the constant terms, we've got 2c2 plus c1 minus c0 is equal to 0. I'm going to say that gives us that c2 is equal to negative 1/2 c1 plus 1/2 c sub 0. For the x terms, we have 6c3 plus 2c2 plus c1 minus c1 equals 0. Okay, so 6c3 plus 2c2 is equal to 0, giving us that c3 is equal to negative 1/3 c2. Since c2 contains our c1 and c0, this is going to give us 1/6 c1 minus 1/6 c sub 0. This process can continue, and you can see that for the x squared terms, we have constants c1, c2, c3, and now c4. So I can express c4 in terms of lower subscripts, ultimately giving us c1 and c0. I'm not going to take it that far because we have what we need to write down 3 terms for each solution. Going back to that y equals c0 plus c1x plus c2x squared plus c3x cubed and so on. We're going to get y equals c0 plus c1x. We get those for free. It's great. Plus c2x squared. Well, c2 is negative 1/2 c1 plus 1/2 c sub 0. So that quantity times x squared is our next term. Plus c3x cubed, but c3 is 1/6 c1 minus 1/6 c sub 0. And I'll put plus dot dot dot. I'm going to parse these out between terms that have c sub 0 and terms that have c sub 1. I'll factor those constants out, and we'll get y is equal to c sub 0 times 1 plus 1/2 x squared minus 1/6 x cubed plus dot 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 plus c1 times x minus 1/2 x squared plus 1/6 x cubed plus dot dot dot, giving us our 2 power series solutions. Y1 is 1 plus 1/2 x squared minus 1/6 x cubed and so on. And y2 is equal to x minus 1/2 x squared plus 1/6 x cubed.